Designing for the real world should not be trapped on a flat screen. That's why we created TinkerXR, an in-situ computer-aided design interface that lets novices design and 3D print objects directly within their environment. TinkerXR enables users to design with constructive solid geometry modeling using their hands. Additionally, users can start printing their models using an AR-based 3D printing workflow available within the system. Here's the general workflow. After scanning their room, users select the workspace they would like to work on. An interactive grid overlay assists users in achieving greater precision during the design process. After the workspace is selected, users can interact with the system via the button menus placed on the wrists, where they can create primitive geometries. With the integrated design features, users can manipulate these primitive geometries to reach the desired results. Once satisfied with their model, users can proceed to the fabrication sequence. The system connects to 3D printers via the server and the printer's IP address over Wi-Fi. A virtual printer twin allows users to adjust printing options and seamlessly initiate the print process. Users can benefit from real-time depth occlusion. Additionally, users can apply a pinch motion while pointing toward objects to select them. Here, the orientation of the weak hand is used for quick logic actions such as single or multiple selection, while the dominant hand is used for selecting and manipulating objects such as moving, rotating, and resizing, with snap-to-grid support for each. Other design features include uniform scaling, combining solid and whole objects, object duplication, ruler tool, numerically adjusting lengths, and more. TinkerXR is capable of handling complex designs, supporting up to 300 basic building blocks and a total of 20,000 vertices in real time. The system enables users to create designs anywhere, adaptable to any environment, whether on a desk, wall, floor, or even suspended from a ceiling. We conducted a user study involving 3 design tasks. We used both quantitative measures and qualitative feedback to gauge user performance. The results suggest high usability, with users reporting ease of use, an intuitive interface, and smooth navigation, experiencing minimal friction during interactions. For more information, please refer to our paper.